Yeah, we are live.
Oh, thank you. So, hello everyone, and welcome to Fluence Developer Community Call number 22. I am very excited to see all of you on this call. And yeah, let's speak about our agenda and have a quick check-in. So basically today we will speak about our highlights on the progress from our development team. So we have Alexei on the call with us today. He will tell us about the new functionality we have recently added, which is called spells and workers. And you will be able to ask him questions about these new cool features. We also have ETHDenver highlights because, well, we had a really exciting participation there. We'll have demos from the teams which are building with Fluence. We have talent player team with us. And you can ask them questions about their experiences. So we'll also have some checkout session, and we will have POAP distribution for this call. So after this call, you have a fancy POAP on your wallet. So let's start. So how are you doing? How is your week? Well, how are you feeling today, guys?
Very good.
Your mic is off.
Again, like, okay. Okay, so let's start with the highlights from our developer team. So Alexei will tell us about the new functionality, about spells. So yeah, spells, what are they? Alexei?
Yep, thanks. One moment, I'll open the presentation and share the screen. Okay, okay. So, do you see these slides? Yeah, well. Yep, good. So, we introduced several new concepts recently, namely spells, workers, installation spells, deals, all that. That's a lot. Let's go through them one by one and start from the most familiar one, to some people at least, and most, I guess, low-level one and most simple one. So spells. What are the spells? Spells are basically just a way to express event-driven Aqua, like not the Aqua that you run from the front end, but Aqua that reacts to some events and like runs in response to something happening. And also it's we had a similar concept. It was called scheduled scripts, but it was missing lots of very useful things. One of which is crucial is state. It was stateless. Now spells are stateful. They have key value storage. So it's basically a service that specifies what Aqua to run, how often to run it, on what events to run it. Right now it's only by clock, by timer, but in the future we will have more. So it's a stateful, event-driven Aqua execution. That's kind of a lot of things happening here, but just to like, it mostly shows the Rust peer architecture, just to dive a little bit deeper into how it all works and might work in the future, because right now we have like only timer events that trigger different spells on different times, but in the future we'll also hope to have HTTP events, network events, and stuff like that. What's important here is that spells are inside this services corner, the services part. So spells are services, but with a special property of providing air script to execute. And Rust peer periodically goes through all the spells and asks what's your script, and creates particle with that script and sends that particle to other peers, or executes it locally depending on what is written inside the Aqua air script. So yeah, that was colorful, beautiful picture. Now back to bullets. So as I said, basically just a recap of what I said. What's important here that I haven't yet covered is that it's possible to have queues in key-value storage of the spells. So that kind of resembles the actor model, but each spell can have as many queues as you want. Right now it's not limited, in the future it will be. So yeah, you can have lists in the key-value storage, and that you can push things there, and you can pop things from there. So some external things like other spells or your custom Aqua or whatever can push messages to the key-value storage, and spell script can pop it from there and like process. So it basically an actor queue, actor mailbox, where like from one side messages are coming, from the other side they're taken and processed by the spell. There is a certain flavor of spells that serves a certain like purpose. It's just an ordinary spell, so it's just a service with some Aqua, but the Aqua there is like special in a sense that we've written it to implement a very narrow thing. It retrieves a list of services and spells to install from IPFS and installs them to the peer where installation spell runs. So what you can have is you can like upload, you can have a configuration like service foo, service bar, spell XYZ, whatever. Here is like name of the modules, here are my configs, here are Aqua functions, and all that. Upload those like definitions, those configuration files to IPFS, get a CID back, and from then create an installation spell with that CID as an argument, and it will automatically download definition from IPFS, parse it, download WebAssembly modules, download module configs, download air scripts, and install all that, like do SRW install, spell install, all that, SRW create, spell install, and you will basically have this automatically deployed bunch of services that are kind of in a box. And also that installation spell does that periodically, in the sense that it checks that nothing has changed, services are still alive and all that, and if some service is dead, it will redeploy the service. If something has changed in the worker definition, like you can change CID because it's in a mutable key-value storage, it will see which services have changed or which spells have changed, and recreate them as well. As I said, it's all inside a box, which actually called worker, but we'll get to that later. It's all in a box, and inside that box we can alias everything. So we'll get to that later as well, but in a fluence.yaml configuration file, you specify names for the services, name for the spells and all that. And those names that you specify, they are human readable. If you make them human readable, and usually people tend to do that, services, it would be possible to call services by those aliases. So alias namespaces are now inside those boxes as well. So whatever like set of services installation spell deploys, no need to know exact service ID anymore. You can just refer to them by aliases, and if some service has changed and automatically redeployed, underlying service ID will change, but no one cares anymore because everything is aliased, and aliases they are inside that box, and they do not conflict with other boxes. So that's great. Automatic deployment. So those boxes, they are called workers. What are they? It's kind of dual concept in the sense that we tend to call worker definition a configuration of services like service foo, service bar, spell xyz, and so on. Those modules, their configs, aqua scripts, all that. We before we upload it to IPFS, we call that worker definition, like, and we get CID from that I was just describing. That's a distribution package side of the thing. The other side is when the worker, the bugs, get actually deployed to the peer. All the services, all the spells get deployed, get aliased, all that. That's a worker that exists on a peer. And besides being a unit of deployment, it's also, as I said, an alias namespace, a box for aliases. It's an isolation namespace. There are certain permissions on who can create services in that box, in that worker. Only the spell associated, the installation spell associated with the worker can create services, and also creator of the worker, like creator of the installation spell can do that, but mostly we target to isolate, so only worker spell, only installation spell can create services inside that box. In the future, we will have separate resource management so that compute providers will be able to limit how much CPU, how much memory, how much disk, and so on certain workers will be able to use. And also some security isolation, keys are separate, like disk is separate and stuff like that. So it's an isolation namespace, and I think we will figure out for more ways to isolate things from workers to workers. Those are isolated boxes. So we recently introduced the concept of deals, and that's deployment of services of workers. Now I can say deployment of workers through a blockchain. But a very useful concept that we had before is direct hosting, when you can deploy certain services to certain peers. So that's where this dichotomy, this distinction comes from. There's a concept of direct hosting where you know which peers you want to deploy to, and there is a serverless hosting where you can declaratively say, I want this worker to be deployed to this number of peers. I don't care who exactly they are. Here's my money, just figure it out. So two different approaches. The direct hosting is very useful for debugging and writing your own nodes and development. And it basically enhances old service deployment model. It's not that different, except that the deployment happens inside installation script. So instead of calling a server create 10 times, you just upload worker definition to IPFS and then say, hey, create an installation spell with that CID, and it installs everything automatically, and there are logs and all that. And in the serverless model, it's almost the same, except that, as I said, you don't know who will host your services, who will host your workers. You just send this CID along some metadata like price and desired number of hosts to the blockchain, and then the compute providers, they listen to the blockchain for events, and whenever they see that certain deal is makes economical sense to host on their hardware, they do that. They download that CID, they create installation spell, and it goes the same way as direct hosting goes, and then they register themselves in service discovery in registry, for example. So that's kind of a distinction that we have. It all works. Direct hosting works, is more mature at the moment than serverless. For example, right now there is no way to opt out of the serverless deployment. So whenever you run your Rust peer, like Jure does, I know, it will host services by other people, and that's kind of not what you want to spend your CPU cycles on. Sometimes you do, sometimes you don't want, and we will provide some ways to opt out of that. But right now, it's all pretty exciting in the sense that you just enter one command and then boom, deploys to the whole network. That's pretty fun to watch. So all that is integrated into the shining Fluence CLI, fresh and crispy. Direct hosting is there. You can do Fluence workers deploy, and after that you can do Fluence workers logs, and you will get some logs. They are we will improve how they look, how they read, and all that, but you can see the logs. That's, to me, changes debugging a lot, because I don't have to SSH to peers anymore. I can just do Fluence workers logs. That's pretty nice. And in serverless mode, we have Fluence deals deploy that basically does the same thing, and Fluence deals logs is almost released, almost there. I believe it's even the PR is completed, just not merged, not released yet. So, and we have how it organized in the Fluence CLI. We have a single YAML file for all of that, single high level one as before, where you can configure services. You can have you say where your service lives. You can have workers. Here, default worker is just a name. You can name it whatever you want. By default, it's default worker. And you specify of what services this default worker consists and of what spells. This example doesn't demonstrate spells, but I will show you in a moment. So, and the next kind of abstraction is the deals, and you specify what worker is in the deal. Only single worker can be in the deal, and you specify how many kind of hosts you want there. So minimum you want one host, at most you want 3 hosts. That's the idea. And when you do having this configuration file, you can do Fluence workers deploy, and only and all the workers will be deployed, but without deals. Just workers will be deployed directly. I will show you how that works. You can specify hosts where to deploy the workers. And when you do Fluence deals deploy, the next section comes into play, and it forms a transaction to the blockchain, sends from MetaMask, all that, with that information that this worker is inside that deal, please deploy. Good. And since spells are a new addition, latest addition to Fluence CLI, even though it all started with them, here's how spell configuration file looks. So you basically just specify from what function you want spell to call and from what file you want it to take, and also how often you want it to run. And there is also an option to set init arguments to that. So good. Let me show you the code. I think I should be talking a little bit more quickly. What is that? That is something wrong. So what I have here, I have a project, just a basic project created with Fluence service new, Fluence spell new, no, like almost no customization. I have a certain service foo here that just has a greeting function, and it takes name and count and prints some string like hello for the third time. And also I have here I have a spell that's called my spell, and it's like here you can see that the buff is specified here, and worker consists of two things, of one spell and one service. All good. This is a direct hosting project, no deals here, but it's trivial to add deals, as you saw. So I have this spell, and in that spell I just specify like, please take function called spell from the file called spell, and provide those init arguments to it. We'll see in a moment why, and run it every 10 seconds, and stop doing so in that much seconds. So the spell could run any Aqua function, as long for now we have a limitation that it takes only like plain arguments, not the objects, I believe, but we will fix that in the future. So what's here? Init arguments automatically go here. They are written to key-value storage, and then when spell is run, they are automatically read from key-value storage. So the values from that configuration file go here automatically. You don't have to like do anything about that. So what it does, it just calls the service, you see. And where did it take the service ID from? We have in .fluence/aqua, the service definitions are automatically generated from WebAssembly files, and the aliases are set automatically too. So there is no more this. No more this. You just import service from service.aqua, and you just call a function, and it's already, definitions are already there. You just use it. And that's basically it. That's how you organize your spells in your project with direct hosting. And for example, if you want to check out the logs, for the for your spell, you can run Fluence worker logs. It will automatically get information from the .fluence. There is a workers YAML containing information about deployed workers. It even prints it here, like spell ID, host ID, and then it just prints the logs as they were written by the Aqua. So for example, hi Folix for the 0th time, it's exactly what I logged here, like greeting, I do log msg, and that's exactly what has been logged. So you have logs, and also you have like more technical logs about like spell deploying, created service, installed spell, created subnet, all that stuff. And that's basically it. I'm done. Any questions?
So Alexey, thank you very much for such a detailed presentation on the spells. I have a question actually. You said that right now, it only allows timer-based events. And what events are planned in the future? So for instance, will it be able to get some HTTP event or some event like from blockchain? So what are the plans for it?
Yeah, hopefully we'll have HTTP events. So we have like design in mind on how to process HTTP requests on Rust peers and send them to spells. So I hope that will happen. And there's a plan for blockchain events as well, though right now we have blockchain can integrate it on services level, not on the Rust peer level. So I'm not sure, maybe it will be kept there and there will be no blockchain trigger. You will have to do that like through other spells. You can always have a spell that listens to blockchain and triggers other spells through mailbox. And yeah, there is also a disconnection trigger possible. For example, you might care that your users connect on or disconnect and update their statuses if you're doing a messenger or something like that. But that needs some strict security guarantees, so no one can spy on your users or you cannot spy on other users. So that's are the plans, but we're looking into more possibilities here.
Thank you.
Hi, it's Jura here. Congratulations with the updates. I got millions of questions. So keep me short because I don't want to take the time from the demos. This may be short. Oh yeah, so I already got some things working today. So I did like I did made a deploy with the serverless option. I made a deploy with the direct something option. But with the latter one, it's like a practical questions. Even though I change things in my Fluence and in the WASM file, it keeps saying that the deal already exists. So what is sort of the ID by which it checks if it's already exists?
So great question. I understand where you're coming from. So yeah, right now we've Fluence deal deploy with that serverless mode. We have this idempotency implemented as a hotfix, because whenever you kind of say Fluence deal deploy after you like the second time, what it does, it just updates updates the definition. So it doesn't recreate the deal, it just sends an update event there. So we check if anything has updated, like if WebAssembly files changed, modules hash changed, module configs changed and all that. And if it didn't, we say like nothing changed, nothing to do. Maybe there is a bug there, but that like idempotency thing, it doesn't exist for direct hosting.
You're saying it's a warning and it does actually change the code. It just says it was already there.
No, it does. So if it says that it didn't do anything, then it didn't do anything. I'm saying that in our experiments, it like behaved correctly, but you may found a bug. And also what I'm saying is that only happens with Fluence deals deploy, but never happens with Fluence workers deploy.
I was talking about Fluence workers. Anyway, it's a typical thing. Let me something more interesting. Also short, hopefully. So now there is a marketplace for deals, and there is a contract which is called the Deal Factory. Do you foresee a future where there could be multiple types of contracts, so multiple marketplaces where peers can then subscribe to? So remember when you said about my situation with my home peer that I could opt out of the marketplace. So if there would be multiple versions of marketplaces with different rules, could you say like, okay, I'm hosting a peer and I want to opt for that marketplace?
Well, it's surely technically possible to implement, and not really hard. Though I'm not sure how it aligns with the like vision and all. I guess maybe Bernard's better to answer that.
You want to do it right now, or do we want to move on and I'll get back to you, Gerard?
Okay.
Yeah.
Thought it was interesting.
Yeah, we can discuss it at the end. Yeah, because we have.
Sorry,
Into the-
I have
into the-
even longer questions, but I'll quit.
Yeah, let's keep them to the end. We have such
Yeah.
in front of us.
Okay, yeah, those were great questions. So right now we will talk about our participation in ETHDenver and how we ETHDenver event and our hackathons. So Nadia, will you tell us more about it?
Yeah. Hey everyone. Happy to share some things from ETHDenver. So yes, you know, at the end of February, there was a huge event in Denver and we participated and we did a lot of stuff there. So not only the main event with a hackathon, but also we held our summit, we have our breakfast and a lot of workshops. We have a lot of like speaking slots and many different events. So here's our decentralized network summit, which is a pretty big event, collecting like a lot of good people from different projects. We're speaking about technology and all the related stuff. So good news that the video from the summit is already out, which was discovered just today when preparing this slide. So here is the QR code there. You can find a link to the whole summit video. There was like 5 talks, which is pretty interesting. So go check it out. And we're going to continue to do this summit. And yeah, probably in Austin, we're going to have the same event. Also, we have Fluence breakfast and a lot of workshops there. So yeah, this is another event with a bunch of people. The next one was ETHVM Hackerbase was very good event organized by Filecoin and Protocol Labs. Yeah, like just event was dedicated mostly to Protocol Labs, but we're always happy to join their event and yeah, give a talk, workshop, and yeah, I don't think that we have videos from those events, but still it was good to participate. Yeah, and the main ETHDenver event, we had a talk. You can check it out also, how Tom speaking. Yeah, we had a booth. There was a lot of people, was more than 10K people there, was really massive. And yeah, it was a hackathon where we have our next slide. Let's check. Oh, one slide is missing for our winners of a hackathon. There was 4 of them. Yeah, here is it. So yeah, we have 5 winners. The one of them was brought to us by Developer DAO. As you remember, during the previous call, we presented you the initiative. So if you want to go to ETHDenver, but like maybe you don't have enough, money to go to buy tickets and etc. So we had a scholarship and we have a team who win our bounties and they are with us today. Hey guys from Talent Layer. Yeah, the Better RPC is actually their project and we are happy to listen to them. Hey again, get your slides ready.
Yes.
Perfect.
So, can you see my screen?
Yes, all good. Please put it in draw mode.
Okay. Yeah. Here. Okay. All right, let's start. So Better PC is the project that we built during ETHDenver. As you can probably tell from the name, it's an RPC solution, but it is trying to do a few things better than current RPC solutions. So let's have a look at the traditional RPC solutions that are currently being used by most of the dApps. We just have a regular dApp frontend, which is talking to an RPC endpoint, and usually this is centralized. So for example, we can think of Infura or Alchemy or QuickNode. Basically, we are just relying on them to talk, to read and write data from the blockchain. And this is simple, it works, but it has a few problems and few improvements that can be done. So what are the problems? Basically, by relying on a single centralized provider, we have a single point of failure. This means that if Infura or Alchemy goes down, our front end goes down. And basically, most of our users can't interact with our application. And this is also, so this is the reliability problem, but we also have censorship problems, because being centralized, these providers can decide to censor or also track IPs, which is something that recently happened with Infura, and I know many people were really happy about it. So this is basically the situation here. Yeah, we have decentralized protocols on chain, which is awesome, but then our front ends are actually talking to centralized intermediaries. So that means that if there are problems, 99% of our users won't be able to use our protocol, even if it is open and decentralized. So how is better RPC different? As we can see from this image, basically right now we're not relying anymore on a single RPC provider, but on many of them. So we still have actually centralized providers under the hood, but not a single one. So for example, we can rely at the same time on Infura, Alchemy, and QuickNode. And also we are not interacting directly with these providers. Instead, we are actually sending calls to a gateway that is self-hosted, which acts as a proxy to the actual providers. And also in between, we have a peer-to-peer network, which is leveraged by Fluence, of course. And basically, this means that we can have some algorithms to orchestrate many calls to different RPC providers to make this more efficient, more reliable. And this can be done in a peer-to-peer way. So we don't have to do this all from a single server, like a gateway, but we can, for example, call many providers using different peers by making this process way more efficient. So the way BetterPC works is that for all these providers that we are using, we're tracking a score. So basically a number that defines how good this provider has been so far. In order for this number to make sense, we need, of course, to have some data and try some RPC calls. So we have a sort of training algorithm. So basically a process that we follow to build the scores until a point where they actually start to make sense. And the algorithm is the following. So when our gateway receives an RPC call, basically it's going to execute the same call in parallel to all providers. And the cool thing is that every single peer is going to call a different provider, how we can see, like we can see in this picture. So this is efficient because we are actually distributing the work to many computers, many peers. Once we have all the responses from the providers, we're going to execute a quorum. So basically, we're checking all the responses and making sure that at least a certain number of responses are the same value. And this is basically for making sure that the response that we got actually makes sense. Because, if, for example, we call 5 different providers and we have 5 different responses, probably there is something else that is not going very well. And so if the quorum passes, we go on and we now update the scores of the providers. How do we do it? We can define several metrics for this. And for the hackathon project, we basically use the following 3 ones. So latency. So basically the fastest providers will get a higher score. And we are also optimizing a little bit here because since every peer is calling a provider, we don't want to have that same peer always calling the same provider, because then we might have actually the peer to be slower and not the provider. So we're also randomizing this part. then we want the providers to be aligned with the quorum. So basically, we increase the score of the providers whose response is the same as the most frequent response. So basically the most reliable ones. And finally, if the provider fails, we decrease the score. And yeah, so this is basically the training algorithm. And the idea is to do this algorithm quite a few times so that the scores that we have for our providers can actually start to make sense. And after that, we can achieve what we call an optimized RPC call, which basically is gonna get all our providers, order them by score, and use the better ones. So it's gonna use first the provider with the highest score to do the RPC call that we want to do. And in case of failure, it's gonna use the second, then the third one, and so on. So basically, we're ending failover so that even if the provider that we think is the best fails, we are still good. We can use other providers. Yeah, that's it. Basically, this is better RPC and briefly how it works. And I'll just go back here. So basically, all the algorithm that explained all the orchestration between different calls is done using Aqua, so the programming language by Fluence. And basically, this allows us to, as I said, to leverage different peers that have different Rust services deployed and orchestrate all of them in this nice parallel workflow. That's it.
Thank you guys so much for sending us to Denver.
Thank you guys, and congratulations again. Awesome project, and yeah, we're happy that you're with us.
Yeah, thank you very much. And actually, I have a question about the project. So is there any way to get the lists of the providers scored? Is there some API for that? So it's very interesting of how you organized all that.
So you mean to actually have data that we gathered during the test that we did?
Yeah. So for instance, to get some stats on what providers have.
Yeah. So we don't really have an API or something for that. We didn't save scores. Something that for now is in memory. So basically, once you start a server, it's gonna start tracking them. But then once you shut down a server, you don't have basically the scores anymore. And of course, this is good for a hackathon project. But of course, this wants to be used in production. Then you need to plug in a database for tracking the scores, etc. So yeah, so far we don't have it. Maybe we can do it. And have it will be nice.
Yep. Thank you. Very nice project. And we're excited to have you on board with our technology. So guys, any other questions?
I think this would be great with in combination with protocols like Anchor and POC network that have behind their gateway have a decentralized way of relaying requests to Ethereum nodes or whatever blockchain nodes.
Yeah, exactly.
Then this is happening before, and then they decentralize the second part of the road of the request.
Mm-hmm. Yeah, so basically this will take it even to the next level. We actually talked with the POC network guys at ETHDenver, and yeah, basically the vision is similar. We probably with Aqua we have more flexibility because we are actually the ones doing the algorithms, so we can decide how to orchestrate all the calls. But then if their actual calls are also to providers like POC network that is also relying on many providers behind the scenes, that's even better for sure.
And the super coolest thing would be that I don't think it's possible now with POC network to host your own node. But if you would host one of their nodes, either POC or Anchor, in combination with a Fluence node, then you could relay it on the server itself without an extra HTTP call, without using the curl adapter.
Oh, yeah, that's definitely a
That would
good.
be the ultimate thing, I think.
Yes.
Hey guys, so any other questions for our awesome hackathon winners?
Thanks so much. Yeah, if we don't have any more questions, we can move forward with different things regarding events. So yeah, actually we're gonna have more this year. So we're gonna be in Brussels for IPFS Pink in April, also in Consensus in April, and Compute Over Data in the early May. So ECC Paris, DAppCon, and Token 2049 is coming like summer and autumn. So actually, like, I think I'm going to share more during the next community goals, but the upcoming is IPFS Pink. It's going to be only developer related event, but you still can meet our developers there. Feel free to join the event. They also have a scholarship if you want to join. Feel free to apply. They have a website and everything there. Consensus is pretty huge event, but like probably maybe we can have a chance to meet some of you there as well. And Compute Over Data is actually also like developer oriented and super specific event. So yes, but for Ethereum CC in Paris, we're also going to have a scholarship by developer DAO. So please like stay tuned and check our updates and news. So probably, yeah, any one of you could also join us as a Talent Layer team does. So yeah, what else we have here? Oh yeah, so yeah, for this community article, we finally have a POAP. This is kind of an NFT, is a proof of attendance. So you can go to your DM right now, check the message from myself, and yeah, just click the link, fill out your Ethereum address or ENS or maybe even email, and try to claim your POAP. This is actually free, so yeah, you don't have to pay for transaction fee if you never did it before. Yeah, that's it probably from my side.
Yeah, Nadia, thank you so much. Guys, please check the links in your DMs. Those apps can be minted for free, so it will not cost you any tokens or whatsoever. And I guess that it's time to wrap up this call. So thank you guys for joining. Maybe you have some questions because we have like 10 minutes or like 8 minutes for this call. So I think we can talk a little bit.
Go for it, Jura. This is your time.
Okay. Do you want to come back to the earlier question with the multiplicity of marketplaces?
Is that your number one priority of the questions?
No, well, not really.
Okay, start with your number one question, then we'll work our way down the list. I know you got an arm's length.
No,
so,
no,
I know we're not going to cover them all. So start with number one.
There's no hierarchy in the questions. Okay, easier. I don't know. Maybe it's also. I was wondering what the thought process was behind picking Polygon for the marketplace.
The thought process was that our first choice, Aurora, wasn't working well, and we had to find an alternative. And Polygon has been proven to be quite capable. So this is just an L2 solution right now, where we're looking at different options.
Yeah.
Now I want to know, why do you want to know why we chose Polygon? What's your like?
Because as you know, I'm always looking at your code, and a couple of weeks ago I saw things about Near and Aurora, and I bought even some coins.
All right, Okay.
And I got myself some fake USD of yours and fake Fluence.
Yeah, we all signed up and everything.
So
but
I
it
was
just
all
wasn't
set on
working.
that, and then then I saw the other one. And apart from that, I have no opinion or any idea that I could have a smart opinion on the choice.
Yeah, we went with the choice that worked.
Yeah, I think that's probably good. Also, like something that was in the announcement that Evgeny did on the thing. You say that that you're moving towards delivery of verifiable proofs of compute. How should I understand that? Or how can I? Maybe the question is, how can, if people ask me about Fluence and I trying to explain that I can orchestrate different data flows between peers, and that you have a way to sort of verify that everything's being done correctly and that we can trust the things that we can build on it. How can I start understanding and maybe in the future explaining the actual logic behind it?
Okay. Eventually, when it's done, we'll have it well documented, of course, so it's very easy for you to disseminate the information. In the process, I don't know if you how much you want to follow it. I don't know. Mike is hey Mike, are you on?
He was just there.
Yeah, I'm here. So yeah, thank you for the
Take it.
question. We have some thoughts about that. So they're not implemented now, but we're like kind of only in a proposal stage. So the first thought is about service result. So yeah, like in Fluence, you could call service, and service is a WebAssembly code, and basically like each WebAssembly code could trick you, yeah, because like for a node provider, it's more easier for just, for example, to return 0 or to return like I know some other stuff and not to do the computation itself. Yeah, because computation requires some hardware resources and all the stuff. And the first thing is to kind of protect against such cases. So generally, there are only, I know, 3 or 2 main ways to protect in the distributed systems. The first one is like, or what would be 4? Yeah, what would be 4? Because some of them are kind of hybrid of others. So the first one, you can just trust the service. Yeah, for example, you know that some good guy like serves this service for you, and there is no reason just to trick you. Second case is to have a reputation-based mechanism. Yes, that we want to have this trust graph. The third case is to have a form of consensus. Yeah, you could, for example, so we're imagining it in a following case. So you write Aqua code, some service, you want to have a kind of consensus to be sure that the result of the service, so you could trust the result of the service. Yeah, and you can write with some form of, I know, like syntax. You can write that, oh, I want to run the service actually on a 20 nodes across a network and compare results and have a BFT consensus or something like that. It's the third one. The fourth one is using ZK proofs. And now we are actively looking into this. So there is a so-called ZK WASM. I believe you heard about that. And ZK WASM is ZK WASM is a really great project, but though it's in a research stage, and it's allow you to obtain proofs that the result of this code is valid. Is it really a result produced by the code that you uploaded? And it's really promising one. But though it's in thank you, Bernard. Though in its research stage, because now 2 major drawbacks. The first one is performance. So it's like this performance is, I know, on real examples, it's about dozens of seconds. It's not so good. The second one is that not all WebAssembly instructions are supported now, but guys are actively working on, and also I also kind of looking to this project. Yeah, it was about service calls, yeah, and we want to provide a way to choose like option from this list of 4 options for every service call. So usually the practice would be something like that. So you can, if you don't want a consensus key or something like that, because it should be kind of paid options, yeah, you can just say that, oh, I trust the result. And it's how work now, yeah, because now you should trust result of services. Or you can, like, otherwise you should do your own consensus in some way. Second option is not about service result, but about registration layer, yeah, about how AquaVM works, or how like all this topology hopes are done, and there are also some thoughts about that. The first one is also to use the key magic. So, you know, like there is in the case there is so-called air arithmetization, and air arithmetization allows you to express some sort of virtual machines in the key. And we hope that in the future we will be able to express AquaVM in the key, and so AquaVM will produce proof that this topological hope was correct, and like on each step this proof could be easily validated. And now, but it's far bright future. Now we are working on the signatures in AquaVM, so you can, like, for example, see last pull requests in AquaVM made by Ivan. So this pull requests, they're intended to introduce signatures, and every node would sign like every service result. And the signature will be put in data that move across network, and then it would be compared on each peer, and each peer would analyze was like peer in the middle tamper data or not. So it's basically for that.
And sort of decentralized system of security of all the peers in the network that they are complying to.
Yeah, kind of that.
Yeah.
Yeah, the main attack that we want to mitigate with that is a peer in the middle or man in the middle, yeah, when some other node could tamper service result from different nodes. And also we need this mechanism for on-chain part. So on-chain we also have AquaVM, and AquaVM will like validate particles submitted to on-chain. And this particle will contain signatures, and AquaVM will validate whether all hopes be correct. Yeah, it's not about service calls, it's only about hopes, that hopes are correct according to the data that such services provide. Yeah, it's a second pillar of verification, validation, and security in our system. So, like, basically two things. The first one is about service calls. There are 4 ways to mitigate them. And second one is about AquaVM and about orchestration layer security and probability.
Thank you.
Hope I answer your question.
I'm going to ask these questions in order for me in a year to be able to answer a question on it, perhaps, you know.
I hope that, you know, like, it's really a tough topic, and we put already a lot of like kind of effort in this topic. We discuss it time to time, and now I'm working on a kind of document about how it should be organized and how it should be structured. So hopefully when we finish with this document, so hopefully if you want, I can share it somewhere. Though it would be just the research, I think that we'll implement it. I don't want like to provide any expectation for that, but hopefully it will be in the nearest future.
Thank you for setting an expectation.
I'm learning not to have expectations. Just a general life thing. Oh,
Okay, guys, so looks like our call is getting to its logical end. So thanks everyone for attending. Shout out to the guys from Talent Layer for their demo, and well, thank you all for attending. Thank you for all your questions, and see you on our next community call. So guys, yeah, have a good evening and see you.
Thank you.
Thank you.
Bye bye.
Bye bye.
but
Thank you, guys.